The journey of solar energy begins in the early 19th century with the discovery of the photovoltaic effect, the fundamental principle behind solar panels. In 1839, a French physicist named Antoine César Becquerel made a breakthrough discovery while experimenting with light and electricity. Becquerel noticed that when certain materials were exposed to light, they generated an electric current. This phenomenon, later known as the photovoltaic effect, would lay the foundation for solar energy technology. However, it wasn't just Becquerel's work that sparked the growth of solar technology. In 1873, British scientist Willoughby Smith discovered that selenium could conduct electricity when exposed to light, providing further evidence of the potential for light to generate electricity. This was an essential step, demonstrating the role that specific materials could play in harnessing solar energy. These early discoveries were pivotal but lacked practical application at the time. Still, they set the stage for future breakthroughs that would change the world forever. Fast forward to the 20th century, when the first practical solar cells started to take shape. In 1905, Albert Einstein made another significant contribution to the understanding of solar energy. His work on the photoelectric effect, which demonstrated how light could cause electrons to be released from materials, earned him the Nobel Prize in Physics. His research validated the scientific understanding that would drive future solar cell developments. However, it wasn't until the 1950s that practical solar cells were developed. In 1954, researchers at Bell Labs, including Darrell Chapin, Calvin Fuller, and Gerald Pearson, created the first practical silicon-based solar cell. This solar cell was capable of converting sunlight into electricity efficiently and was the first step in transforming solar energy into a usable resource. This silicon solar cell, though relatively small and inefficient by today's standards, was a game-changer. It marked the first real step in making solar energy viable for practical use. However, the technology was still costly, and widespread use of solar power was still years away. The next critical step for solar technology came in the 1960s, when solar panels found their first major application in space exploration. Solar panels became a vital energy source for satellites and spacecraft. In 1958, the Vanguard 1 satellite became the first spacecraft to be powered by solar energy. It demonstrated that solar panels could function in the harsh conditions of space, marking a significant milestone in solar energy's history. With this success, solar panels were used in numerous space missions throughout the 1960s and 1970s, further proving their viability and efficiency. As a result, solar energy was no longer seen as a mere experiment but as a legitimate source of power for high-tech applications. The 1970s were a transformative decade for solar energy. The global oil crisis, marked by an increase in oil prices and concerns over energy security, led governments and organizations to focus on alternative energy sources. Amidst rising energy costs, the world began to look more seriously at solar power as a potential solution to the energy crisis. During this period, funding for solar energy research surged, and solar panels began to receive increased attention. The cost of solar panels began to decline, though they were still prohibitively expensive for most consumers. Still, the interest in renewable energy grew, and solar energy became a part of the global conversation on sustainability. In the 1980s, the rise of environmental concerns and a growing awareness of climate change drove further innovations in solar technology. Companies experimented with new materials, including thin film and amorphous silicon, in an attempt to lower the costs of solar panels. While solar energy was still in its infancy, these years laid the groundwork for the advances that would follow in the 21st century. By the 1990s and 2000s, solar energy had become a more prominent player in the energy market. Advances in technology such as improved manufacturing processes led to lower costs and higher efficiency. The adoption of solar technology grew, and solar panels began to be used for residential and commercial applications. In the early 2000s, solar farms started to emerge. Large-scale facilities designed to harness solar energy on a massive scale. These farms were primarily located in areas with abundant sunlight, and became essential for providing solar power to local grids. As the cost of solar energy continued to fall, governments began to introduce policies and incentives to encourage the development of solar energy. At the same time, the development of thin film and concentrated solar power technologies helped increase the efficiency and economic feasibility of solar energy. These innovations made it clear that solar energy wasn't just a niche technology, it was poised to become a mainstream source of power. Today, solar technology continues to evolve rapidly. Solar panels have become more efficient, affordable, and accessible than ever before. Advances in perovskite solar cells, solar roof tiles, and bifacial solar modules are pushing the boundaries of what's possible with solar power. Additionally, the development of energy storage solutions, such as lithium-ion batteries, has addressed one of the biggest challenges of solar energy: its intermittent nature. With energy storage, solar power can now be stored and used even when the sun isn't shining, making solar energy a more reliable and consistent source of power. As countries around the world continue to adopt renewable energy solutions, solar panels are playing a crucial role in the transition to a more sustainable energy future. The origin of solar panels is a story of scientific discovery, ingenuity, and persistence. From the early discoveries of the photovoltaic effect to the modern, efficient solar panels we use today, solar energy has undergone a remarkable transformation. As we continue to innovate and improve solar technologies, the sun will remain a vital source of energy, offering a cleaner, greener future for generations to come. Thank you for watching. Please like, subscribe, and turn on the notification bell for more.